Okay, so in this video, we're pretty much just, this is the application of polynomial equations. So I'm going to read this all to you, and then I might have to erase some things because obviously, as you can see here, most of the board is covered in writing. So an open-topped box can be made from a sheet of aluminum measuring 50 centimeters by 30 centimeters by cutting 4 congruent squares. So that means the squares are the same in shape and in length from each corner and folding up the side. The volume of the box is 4,000 cube centimeters. We have to do two things here. We have to determine a polynomial function representing the volume of the box, and we have to determine the side lengths that are possible for the square cutouts, rounded to decimal places if needed. So I'm going to erase these two things here, but you can always rewind the video if you need to refresh your memory. Okay, so with these types of questions, I like to draw a diagram. So I'm going to draw a diagram of the sheet of aluminum as it is. So it's a, what is this? It's a rectangle because 50 and 30. So I'm going to say this is 50 centimeters. And I'll say this is 30 centimeters. So this side's 50, that's 30. Okay, so notice how it says an open-top box. So an open-topped box can be made, so it can be made from this sheet of aluminum, measuring 50 by 30 centimeters by cutting 4 congruent squares from each corner. So we're gonna cut 4 congruent squares from each corner. So 4 congruent squares from each corner. So these are squares. I know they're not exactly, but I'm a human. So these are the 4 squares that we cut out to make the box. So once we cut these corners out, okay, so I just want to read this again to you. So actually, I'm not going to do that. First thing I'm going to do is, as you can see here, now actually I will read it out to you. So, okay, so I'm going to read the key details here again. So an open top box can be made from a sheet of aluminum. So this is the sheet of aluminum, and it measures by 50 by 30 centimeters. And you can build this box by cutting 4 congruent squares from each corner and folding up the side, or the sides. So as you can see here, we cut out these 4 corners. And once we do that, these are all congruent. They're gone. So we can erase this and this. These are gone, they're cut out. Hopefully you can see what I'm doing here. Okay, so these 4 corners are gone now, they're gone. And we can build the box by cutting out the 4 squares and folding up the sides. So these sides here, they're gonna be folded up, and so this side's gonna come up, this side's gonna come up, these sides are gonna come up, and they're gonna make an open top box. So hopefully you notice that once you fold the sides up, for example, so once it's like this is on the ground right now, but once you fold it up, so if you fold, why is this not working? If you fold this up, this is going to be your height. We can say x is your height. If you fold this up, this part right here is going to be your height. So here, now this cube is not representing this, but I'm just showing you how I'm just showing you that once, so this does not represent this, but I'm just showing you how that once you flip the corners up, this is going to be your height. Same thing here. When you flip this corner up, this is going to be your height. This part right here. So this part would be equivalent to this. It'd be the height of the box. And I'm going to call that x for this question. So now that that's clear, I'm going to erase it, and I'm going to solve the first question, which is to determine a polynomial function for the volume of the box. Okay, so the equation to find the volume of a box is equal to v times length times width times height. So, if you remember, actually I should have probably kept the diagram. So, here. This is what the diagram looked like, I think. Okay, so if you remember correctly, these are the 4 squares that we cut out. And we knew that before, this entire side was 50. And this was 30. So before we cut the squares out, here, we can do this actually. So this was the original sheet of aluminum. And this whole thing was 50 and this whole thing was 30. But we cut these squares out, so now they're gone. So to find the length is going to be equal to 50, and we have to subtract 2. We have to subtract 2 lengths, or as I explained earlier, we can call the height equal to x. We can say x represents the height. So the length is going to be equal to 50, because 50 was the length of the whole thing, minus 2x, because these 2 squares are gone. And we can do the same thing for the width. So it's going to be times 30 minus 2x. Same thing, 2 squares are gone. Then we, as I said earlier, we can represent the height using x. And then just to make this neater, or to put it in a format that we're more familiar with, we can bring this x to the front. So I'm just going to rewrite the equation, but we can just bring the x to the front. So like that. So this is a polynomial equation that represents the volume of the box. So now, before we do anything else, I'm just going to write this here. Volume is equal to 4,000 cubic centimeters. And we got that from here. And now I'm going to erase the word problem because I need more room to show my work. So give me a sec. Okay, so I apologize, but I forgot to mention this earlier. So anyways, before I before I talk about what I should have said earlier, we have to find the potential dimensions for the square cutout. So basically, when these squares were still here, these were the dimensions. So this right here, this right here, this right here, and this right here. Those were the dimensions of the squares. And as I said earlier, we can let height be represented by x. But I forgot to mention that when we cut out the squares so that it looks like this, the squares are gone. When you fold this up, when you fold this side up, this is going to be your height. We can represent it by x. X also then represents the dimensions of the boxes that are cut out. So like, for example, this is a whole box. Pretend there's a box. Pretend the box was there, or the square. Pretend the square was there. We have to find the dimensions of this square, and since the height, when we flip this up, this is our height. This is also a dimension of the square. So we can say x represents the dimensions of the squares as well. And hopefully you can see that since we're letting x represent the dimensions of the squares, all we have to do now is we have to plug this in. So we have to plug 4,000 for volume. We have to bring everything to one side. We have to distribute everything. And then we have to factor whatever we have to find x. And once we do that, we find the dimensions of the square cutout. So hopefully that makes sense, more sense as I do it. I apologize though, I should have mentioned this earlier. So I'll keep this here in case I need to reference to it again, but anyways, we're gonna say 4,000 because the volume is equal to this from the question, equals x times 50 minus 2x. 30. Okay, so I just plugged in 4,000 for volume. Now I'm gonna bring all the, actually no, before I do that, okay, so I plugged in 4,000 for volume. So now what I'm gonna do is I'm gonna distribute everything here. So once you do that, so x is going to be equal to, okay, so not to waste time, I just performed the double distributive property with these two brackets. So now, once you do that, once you do the double distributive property, this is what you get. And then I'm gonna just rewrite this out again. And now you have to distribute the x to all of these terms in the brackets. So this is gonna be 1,100x. It's going to be 160x cubed, and this is going to be x squared, my apologies, and this is going to be 4x cubed. And now, to make this more neat, I'm going to just say 4,000 is equal to, I'm just going to bring this to the front. I'm going to keep this in the middle. I'm just going to move this to the back because it looks neater. And now I'm going to bring the 4,000 over to this side. And when I do that, this is going to be equal to 0. The left side is going to be equal to 0. And this is what we get. So this is what we have now. So now hopefully I put this in a format that's better understandable, that's more easy to understand. And now that we have this format, all we can do now is we can factor this and solve for x. And once we solve for x, we figure out what are the possible dimensions of the square cutouts, because that's what the question's asking. So I'm going to erase all this, put this to the top, and I'll factor this. Okay, so now I just brought this equation up here. Now to find x, I'm going to use the factor theorem. So I'm not going to show that on screen to save time, but I'll return once I have performed the factor theorem. Okay, so now, now that I'm back, basically I used the factor theorem. So I figured out that 5 was a factor of this polynomial equation, because when you plug in 5, that equals 0. So therefore, x minus 5 is a factor. So now that I know x minus 5 is a factor, I used synthetic division to figure out the other factors of the polynomial equation. Now, after I performed this synthetic division, this is what I got. So now we can say that 0 is equal to the x minus 5 times 4x squared minus 140 plus 800. Okay. So this is already factored. This is good. Now, notice how, I don't know if you remember this, but in the question it said we have to determine all possible side lengths of the squares that were cut out. So we know that x5 could be a potential answer, but we have to figure out all the values of x. So we have to factor this though. Now, since, sorry, this is supposed to be 140x. I don't know why I missed that. But anyways, now I'm gonna use the quadratic formula to find the potential values of x here, because these are very big numbers. So basically, I'm gonna erase this here. So we have x is equal to negative b plus or minus 4ac 2a. So now I'm just going to plug in the values here. Okay, so to save time, I just plugged in the values of this into the quadratic formula. And this is what we have. So now I'm just going to solve for the potential 2x values. And after we do that, we'll be pretty much done. Just one more step after that. So, okay, so after performing the calculation here, the two potential x values are 27.8 and 7.19. And this x equals 5. This came from here. We just set this to 0 and I wrote that here. So these are the potential, not the answer, but these are maybe potential answers to the dimensions of the square. But we have to check these answers now. Now, hopefully you remember, I apologize, there's been a lot of writing and erasing here, but we actually don't need this anymore. So I'm going to erase this. I'm going to erase this here. And hopefully you remember our answer to the first question, which was we had to find a polynomial equation to represent the volume of the box. And that was equal to x times 50 minus 2x times 30 minus 2x. I believe this is what it was. Okay, so hopefully you remember now that our answer to the first question, which was find a polynomial equation to represent the volume of the box, was this. And 50 minus 2x represented the length, and 30 minus 2x represented the width. So as you can see here, I plugged in these potential x values for what the dimensions of the box could be into the terms or the expressions that represent the length and the width. So as you can see here, for 5, we get 40 and 20. So that's good because they're positive values. So yes, 5 works. 5 is a potential dimension for the square cutout boxes. Now 7.19. When we plug that in, we get positive numbers. Perfect. 7.19 is also a potential x value for the dimensions of the box. But when we plug in 27.8, we get negative values. And it's not possible to have a negative length or a negative width. So we know that 27.8 does not work. So this is not a value because we get negative lengths and widths if we plug in 27.8. So therefore our answers are, remember now, I don't know if you remember still, but our unit of measure was in centimeters. So our answers are 5 centimeters and 7.19 centimeters. So these are the answers. So 5 centimeters and 7.19 centimeters are the two possible answers for this question. The 5 centimeters and 7.19 centimeters are the two possible side lengths for the square cutout. So that's the answer. I apologize for the lengthy video and I apologize for leaving some things out until later. But yeah, that's the answer.